Jarvis, you there?
At your service, sir.
Oh my God.
I can't feel anything.
I'm here.
So my friends, meet Neil Harbison. He was a man born with the disorder of achromatopsia. What that means is his entire world around him was in shades of black, white or grey. But as always, technology came to the rescue. He built himself a skull implant which he calls the iBorg. It has a color sensor here which detects the changes and the colors and transmits them through his skull in the forms of notes of music. Now, he wears clothes which sound good to him. He looks at paintings or colors which sound good to him. Technology has brought colors into his life, and it can change yours too.
Now, we've already seen how transhumanism has transformed one person's life. Now, let me get to what transhumanism essentially is. Now, for those of you who are fond of definitions, this is the boring ones. It's just a class of philosophies, it basically tries to push the human race beyond what it is. It's a class of philosophies that aims to use science and technology to push the human race beyond what it is at the moment. Now, this could be in various forms. The major thing that I am most interested in and that we are going to be covering right now is how you can use, scientific things, like you can use science and technology like cyborgs, you can use prosthetics, you can use things like mind uploading, nanobots, extremely out of this world technologies to push the human race forward. Now you might say, isn't that the purpose of all of technology? What makes transhumanism different? Now, a lot of technology is focused just on improving the environment around you. What transhumanism does different is it focuses on changing you instead. It has to change the human body. The focus is to improve the human body from within. Not just the human body, the human mind, everything about us, our genes. Improve all of that. That is what transhumanism is about. So now, let me get to why we need this. Why do we need this? Why can't we just be how we are? So for this, let me narrate something that actually depresses me a lot. It goes like this. We are a very intelligent life form. We are the only intelligent life form we know of. So it would be very meaningless if we just lived our life, died, lived our life, died, lived our life, died, and then many centuries later, a few billion years later, even if we are alive till then, there'll be a massive extinction event and we'll all just die. That's just saddening. The fact that the all of human race, the smartest civilization we ever know, is just going to die. So what this aims to do is quite a few things actually. Extend our lifespan so that we can make as much use of this as we can. And a wide range of other things, even things like multiplanetary expansion, or even getting rid of our bodies, and a wide range of things that can stop us from falling prey to this extinction. Now let me narrate another story which forms a very important reason for transhumanism. So this is the story of something called the neocortex, essentially this thing that you can see over here, forehead. So now how is this related? So the story goes back 200 million years ago. So what happened then was there was a massive extinction event. All the dinosaurs and all the major reptiles of that time, they all died. But then the mammals of that era, they did not die. Why is that? So this is a structure of the brain. So what was there in the mammals at that time was this part, this neocortex. What the other animals at that time had was only the reptilian brain and to some extent the midbrain. Now, the difference between the neocortex and the rest of the brain was this. The neocortex gave you the ability to change based on the surroundings, to change your behavior. Maybe, if there's some bug, if there's something coming to eat you, think of new ways to escape from it. Think of new ways for survival. That increased the survival chance for mammals. Why didn't reptiles have this? Because they relied merely on genetics to improve them, and that would take way more than thousands and thousands of years to improve them, which obviously wasn't enough. While with the neocortex, this could happen in a matter of seconds. So now that time life took a huge leap. It moved away from genetic transformation to everyday transformation. And that is what's there even in us. That led to the advent of language, that led to the advent of maths, science, philosophy, art, everything that we love today. And now how transhumanism comes into this is something very interesting, that one day we'll all be able to share our neocortex, as in our neocortex, which is, by this small things, you can't leave this. So the idea is that one day we'll be able to have a cloud of neocortex, maybe a cloud that's literally everywhere, which you can use for thinking, that will provide us additional amount of consciousness, additional amount of abstraction, where we can think of higher levels of things. And this is how you can actually unlock a wide range of ideas because of that. Let me get to another major reason for transhumanism. Now this, you may have heard of it, it's called the Maslow's pyramid of hierarchical needs. So what it says is, the way humans think of their needs, it's like, first comes our physiological needs, our health, that's essential for us to survive. Then comes our safety, and then our love, belonging, our self-esteem, and then something called the self-actualization, which is essentially being able to do what we love, living our dream, doing something big. Like, that's what humans live for, right? Now, the problem with the present existence is that we spend too much of time on these physiological and these safety aspects. We spend a lot of time on making sure our health is fine, our bodies are fine, we're well protected. But with the advent of transhumanism, what could happen in the future is all this is managed by our robotic parts, our non-biological parts. Things that could do it for us on its own. We don't need to go out there and do it. So these could essentially be eliminated with the advent of transhumanism. And all we need are these natural human traits. Essentially, what defines us as human, what sets us apart from other living beings, is our love for others, our social relations, our self-esteem, and it'll obviously be much more easier then for us to live our dream the way we want to. Now, let me get to the major aspects of transhumanism. I'll also be covering a bit on the technologies over here. So there are essentially three aspects: super longevity, super intelligence, and super well-being. So super longevity ranges through a wide range of things. It's essentially increasing your lifespan, and even that we're even exploring, immortality. How we can keep ourselves immortal, how we can keep our consciousness existing forever. So one major technology in that could be maybe mind uploading. So that's one huge thing in that. And people are also working on a wide range of anti-aging techniques. All that comes under transhumanism. Now, super intelligence. Now the mind uploading, which I talked of earlier, that can again come over here, because you can share a lot of brains over here together. And another major aspect in this is artificial intelligence. So that could actually change things a lot for us. And finally, let me get to super well-being. Now, I may be an immortal person, I may be the smartest person on the planet, but what's the point if I'm not happy? What's the point if I don't have good thoughts? This is what super well-being talks about. So essentially, it says that we can have these kind of drugs or genetic editing that can actually keep us happy forever, that can keep us stimulated always keep us high on energy. So that is what super well-being is about. Another aspect of that could be having the baby the way you want it to be. You can actually design your baby. So but then that comes to a very ethical question, or a sort of whether it will help us or not. One argument against super well-being could be that, well, we learn a lot from suffering. The suffering is what teaches us new qualities. So that is something that can be debated upon.
My friend talked about the different aspects of transhumanism, but the proof that it will be achieved, or rather it can be achieved, is the technological singularity. Before I go on to explain what it is, I would want to first explain a few terms before that. The Moore's law. Gordon E. Moore, the founder of Intel, had stated this a lot of years back, that every year the number of transistors on a chip doubles and the size of the chip is halved, and this is every single year. So imagine the amount of technological improvement in a year, because the transistors on a chip is what decides the computing power or the processing power of the computer. So let me give you an example which would make it really clear. Suppose we add 1,000,000 transistors on a chip every year. 1,000,000 transistors on a chip is a lot, okay? Isn't it a lot? So if we add that every year, in 30 years we would have 30 million transistors. But if we follow the Moore's law, in 30 years we would have 1 billion transistors, and if we start with truth transistors. So look at the difference, look at that amount of technological improvement in such a short span of time. The Moore's law has held true all these years, and should be holding true the coming years also. So now this is what we believe will lead to the stage called as a technological singularity. So there are two ways to look at the technological singularity. One is that when you plot the technological improvement, the computing power of computers on a graph, it won't be linear, but it will be exponential. That means that it would be a curve, the upward curve. So if you look at the graph at one point of time, it would almost be like a straight line. And that line is what they call the technological singularity. Or the second way to look at it is this graph here. The human intellect or intelligence had started out from zero, or when the humans came into this earth, of course, and it has been growing in a more or less linear way from that point of time. And machine intelligence has started up at about 1950, and it has a really big curve from then. So the meeting point of this, the two intelligence, the intellectualities, the human intellect and the machine intelligence, is called as a technological singularity. This is when our intelligence, human intelligence, will be that of the level of machine intelligence, and machine intelligence will of course continue to go on. And that point of time, we will truly achieve transhumanism. So when we achieve the technological singularity, we will move into this phase called post-humanism, where we humans will be called as post-humans. So during the post-humanism stage, every single day there will be so much of technological improvement. We will strive to become the perfect, or we will strive to become a better version of ourselves. There will be so much of improvement in us that it wouldn't be even able to, that we aren't even able to comprehend it. Like right now, with the simple minds we have, we cannot even think about what kind of developments will take place during technological singularity. And this is what we want to achieve through transhumanism. This is the aim of transhumanism, post-humanism, the perfect version of ourselves, the better version of ourselves, improving every single day, becoming better every single day. That is the true aim of transhumanism.
So now that we've talked about what transhumanism really is and all its aspects and why it's there, a lot of you must be wondering that there's no point of it because it's not possible. It's just wishful thinking. It's something that can't be done, or something that will take thousands or millions and millions of years. Well, we will show you a few technologies that are already implemented in many aspects of transhumanism, and there's a lot of research and development going in this in this direction, which will show you that this is actually happening right now. There are a wide range of technologies that are already being worked on. Now, from the simple like prosthetics to the most complicated things like mind uploading or nanobots, there is a lot of research going on in these areas right now as we speak. So now, the first one that I'm going to be addressing right now is mind uploading. So, one thought that comes to mind is, if we're an intelligent species, of course, so now everything that has lived till today, every form of life has died or is going to die in the future. Now that's probably going to happen to us too, unless we figure out a way to be immortal before that. So the question arises, does all that we've learned, all that we've thought of, our consciousness, our abilities, do they just die with us? Can the human civilization make use of it even after we are gone? Well, this is what mind uploading tries to address. So imagine, instead of you dying, or even if you in the physical body die, if you could live in your mental self, if you could upload your mind to a computer elsewhere, and that could still live as you. So how this would work is essentially our brain is also a series of a large number of neurons, essentially 86 billion neurons in 1 trillion synapses. Now there is no reason why this has to work only with organic materials. You could make this kind of a structure with basically any material. So your brain could actually run on some other substance. Now, just in case, now this could provide a wide range of solutions. For example, if you keep forgetting something, just put a button up here, press it and you remember it. Or if you want to learn something immediately, you can just upload that onto your brain, or download it rather, from the web of consciousness. Okay, so now just in case you guys are wondering that this is again just wishful thinking and it's science fiction, let me tell you, this has already been done in obviously a much smaller aspect. So just a couple of years back, a memory was actually recorded for the first time. So a rat, it was taught to do a specific task, and then they waited till it forgot how to do it. Now this recorded memory was uploaded back into it, and startlingly what they observed was that it could in fact do those tasks again. So that's just one brilliant example of how this could be done. And another example is this thing called the Open Worm Project, wherein there's this species of worm which has just about 302 neurons, which is very small compared to 86 billion neurons in our head. But they actually took that and uploaded its brain into a robot. So here's a video of that.
It may not look like one, but this robot is actually a simulated worm. Scientists from the Open Worm Project, an open source program dedicated to creating the world's first virtual organism in a computer, have created software that simulates a common roundworm by using a complete map of the neural connections inside its brain.
Now let's talk about the mysterious and fabled artificial intelligence. So for those of you who don't know what AI is, it's basically the development of systems that require a level of intelligence to perform complex tasks that require massive intelligence. Next slide please. So present day AI includes Cortana, Siri, Google Assistant and so on. Next slide please. This list also includes IBM Watson. So here's a fun fact. IBM Watson was actually played a game called Jeopardy. And Jeopardy is a game that involves communicating through natural language, and it involves a lot of thinking. So Watson actually won over the two best players of the game, and that's hands down. You can see the points that it has 77,000, almost 50,000 more than its competitors. So that's the rate of development of AI. You can literally see it in this picture. The picture explains a lot actually, if you think about it. Next slide please. So now let's come back to this picture. Friends spoke about the singularity. So the singularity is the point where our intelligence, which goes in a linear path, and converges with the intelligence of machines, which goes through an exponential path. And this point is where we attain singularity. So at this point, we will have a thing known as human level AI. So human level AI is a stage at which the machines will have as much intellect as humans in all aspects. So it will literally be able to do everything that we do right now, not in terms of actions, but in terms of computing and all of that, in terms of tasks that require intelligence. And then after that, this AI will move at an exponential pace, and after this it will be known as strong AI. Strong AI is a phase where intelligence will be exponential and beyond comprehension of humans as we know them today. So that's how it will go on, and it will keep learning at an exponential pace. So this will never slow down.
Now let me show you an AI-based program that we created on our own.
What it basically does is that it takes hotel or restaurant reviews from the user and then tells how positive or negative or neutral the statement is. Based on that, it gives percentages for each of the above mentioned criterias. Now let's give it a try. So as you can see, for positive statements, there's a high positive value, whereas for negative statements, there's a high negative value. So what's so great about this? Well, it recognizes natural language used by the user, and this is where AI becomes essential. Now, many of you put stars on Android Play Store while reviewing apps, right? Now, what this program will ensure is that there'll be no requirement for you to rate the app. All you'll have to do is input your comments, and based on that, the computer will be able to review the app on its own.
So cybernetics is basically a stage where we'll be able to communicate with things around us. So our brain will literally be able to communicate with all the appliances around us. So next slide please. Yeah. So this basically expands the internet. It's an extension of the internet by using our brains. So many of you would have heard of IoT, which is the full form is Internet of Things. So this basically uses the internet to connect to various appliances around us and control them by giving a command through the net from anywhere. So now this can be done by our brain also. So the brain can be literally an extension of the internet where we actually just think about something and it happens. So that's really crazy. That's a crazy idea and I can't wait to see that day. Next slide please. So now, as we keep talking about this, many of you would have heard about cloud computing. So cloud is basically where we store some of our data into external databases because we want to minimize the things that because we have limited resources, right? So now, the same thing can be done with brains. Imagine you have a complicated math problem to do. In India, okay, you live in India and you have a test right now and you have a complicated math problem to do. And now out there in the US, a guy is sleeping. He's not using his brain, except for dreaming maybe. So now what you can probably do is, and you don't have the required computing power to do the mathematical problem in the given time. So now you can borrow the brain power of the other fellow person who's sleeping in US. So you can borrow his brain power along with yours and then solve the complicated math problem in literally no time. So this is basically, sharing of brains. And this is known as a brain net. So it's all the brains communicating with one another and forming a complex system just like the internet which connects computers. So this way we'll be able to give or take brain power from each another and hence able to achieve the impossible.
So friends, I will now tell you about a form of transhumanism that can transform the lives of our entire genome. It can transform the lives of our children. It can remove many serious diseases that still pose a problem to our human civilization. Genetic engineering. This can change the way humans go on from generation to generation. I will now speak about a few subtopics under the genetic engineering. Next. But first, I will tell you how DNA editing or genome editing works. So, in genome editing, a nuclease, or in common terms, a molecular scissor, is used to cut out a part of the DNA. Next, that when the DNA recombines at the adjacent places of the cut, there is a slight change or an edit in the DNA, and this further goes on and gets passed on generation to generation. Now there are many parts in this. So in genome targeting, it's very similar to genome editing. How, you ask? Well, the nuclease or the molecular scissor is used to remove a part. How is it different then, you ask? Well, after removing the part of the defective, let's say, DNA strand, another DNA strand is inserted there to make another difference or a mutation. This has been tested in animals such as mice to remove probably skin defects, let's say spots, or in a Dalmatian to remove all the black spots or make it completely black. This kind of a DNA editing or DNA targeting has been used. Next slide. This is a diagram which briefly explains how the present scenario of gene therapy works. Well, an adenovirus is used, which is specially incubated in lab conditions with a part of a DNA strand. So that is introduced in the cell, and through a vesicle it enters the nucleus through a nuclear pore. So when it enters in the nuclear pore, well, the adenovirus, it removes the defective part of the DNA strand and it inserts the new stronger part of the DNA strand. This helps in mutation for the benefit of our human civilization. This comes under, let's say, the super well-being that we previously spoke of. Using gene therapy and genetic engineering, we can decide how our children should be. We can decide what they should have and what characteristics they shouldn't by just removing the selected DNA strands and inserting better ones. This is now being thought of and conceptualized to be done by nanobots. Next slide, please. Here is Aubrey de Grey. He is a biomedical gerontologist. What is a gerontologist? It is a man who studies the science behind aging and tries to prevent it at its root cause. Aubrey de Grey is the founder and the funder of Sense Foundation. At present, he is the chief science officer at the Sense Foundation. Here you have. Well, he has conceptualized a method wherein he can add probably 30 years of good living to a person who's already 55 to 60. Now what he conceptualizes is he can make us immortal and give us the factor of super longevity. How? Well, he can give 30 extra years to a 55-year-old, and what he says is by the time that set of 55-year-olds become 80 or 90-year-olds using those anti-aging drugs or those genetic engineering, there will be further more research done, and further they can be given more 25 years, and like that people can be pushed farther and farther towards being immortal. He has done a lot of work for anti-aging drugs to provide super longevity to our human civilization. This is about all of genetic engineering, and this can help us and our generations further improve and become better.
Cryogenics is another aspect of transhumanism, where whenever you want or when you know that you're gonna die, they freeze your body under low temperatures in liquid nitrogen, and they do that there is a hope that in the future, when we will be able to achieve posthumanism or transhumanism, there will be hope that your body can be revived and be brought back to life, and that you were just sleeping all that while. So cryogenics is a way to preserve human bodies, and after several thousands of years, when we achieve transhumanism, revive them back or upload their thoughts onto the net and live forever.
Prosthetics is one aspect of transhumanism that's already been built a lot nowadays. So we all know what it is. Essentially, if you don't have a limb, you can attach a new limb. If you don't have anything, like nowadays you even have brain prosthetics. So you can have prosthetics for pretty much anything now. Now we have built a very crude version of a prosthetic. And this is the project that we're going to present today.
We call it the bionic finger.
Yeah, it's a voice controlled bionic finger. Now before we present that, let us show an app that we've built to control this.
Now we'll be talking about the Blue Voice app. So this is an app we made to support our project. Next slide please. This app was made by us using MIT App Inventor. So what it basically does is it uses Bluetooth to connect with the Bluetooth module on the Arduino, and then it transmits commands, voice control commands to the Arduino. So it uses the Google voice recognition API for this. So the voice recognition API basically recognizes what we speak into it, converts it into text, and then later on the app sends it to the Bluetooth module in the Arduino.
So here we've built a very crude form of transhumanism, which is prosthetic. So under that we've made a voice controlled bionic finger. So let's say you don't have an arm, or you want an arm to do extra functions for you. Then you can just say, point this finger, do that. Tell it to do something and it will do it for you. So we've used Arduino, the HC05 Bluetooth module and Android to do this.
So this is just the basis for what we want to do in the future, which our friend has already talked about. So here we have a device, and we've connected the device through Bluetooth with the help of through the Bluetooth module. Now he's going to use his voice to trigger this.
Point.
So now as you can see, when he said point, this thing points the finger.
Back.
And now it goes back. And another application of this would be not just in transhumanism, but if you want to remotely control a robot or something of that sort, then this can easily be helpful in something like that.
So it is a robotic cum prosthetic finger, which we call as the bionic finger.
So now let us discuss about the future plans of our project. So we felt that our form and function weren't that great. Next slide, please. So we came up with a few new ideas. So we changed the design slightly. Instead of using wood, we will now be using polymer, which does not react to water, that is, biologically resistant, so that it can be more wear and tear resistant too. And then we'll have flexible yet form retaining wires passing through that, which act like the backbone of the fingers. So when these strings by the servo get pulled and released, the form retaining flexible backbones will stretch back or spring back into the mean position, and this can give you high articulation later on. You will not need two servos on two sides per finger. You will just need one servo. That can reduce your cost. So now we could add one servo per finger to increase and make it high articulation of the future hand. So let's say if we need the second hand to hold the phone or the pen, we can have that second hand. Why second hand? When you need more hands, you can have more hands, because this is not only a prosthetic but can come as different resellable modules also. So then when you need the second hand, you have the second hand. You can hold cups, you can hold phones, and you can hold pens. So you have a high articulation and every finger can bend separately. Now for the control, at the present finger model which we have made, we have used the Bluetooth control and the Google voice recognition to help us either point or bend back into from the mean position. Now we have thought of different other possible controls. For example, tapping multiple times with piezoelectric pads, which could sense pressure and convert them into controls. We could also take blinking into account, or we could have preset buttons or preset controls. For example, let's say you're going for a cycling tour, so you could set it beforehand into the cycling mode, wherein all the controls necessary for a cycling tour would already be there. So when you speak, only as per what it means in the cycling preset section, it would change the way your hand functions. And this is how our future plan works.
You can contact us at these emails, and thank you so much for watching.